Hello and welcome to another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 3, Lesson number 5 on inverses of linear functions. So back in Unit number 2, we looked at inverse functions. Today we're going to concentrate specifically on the inverses of linear functions. This will review a lot of things we already know about inverses and things we know about linear functions, so it should strengthen us on both topics. All right, let's jump into it. So in the first problem, it says on the grid below, the linear function y equals 2x minus 4 is graphed along with the line y equals x. Letter A, how can you quickly tell that y equals 2x minus 4 is a one-to-one function? Do you remember this? Pause the video for a minute and think about this. So because it passes, that almost looks like passes the horizontal line test. Remember that? We had this test that said, and I'm going to get rid of some of these in a little bit, but said, if I draw a horizontal line, remember we're looking at just this line here. If it strikes the function only once, well, then it's a one-to-one function. And if it doesn't, if it hits it more than once, it's not a one-to-one function. All right, so it passes the horizontal line test. Letter B says, graph the inverse of 2x minus 4 on the same grid. Recall that this can easily be done by switching the x and y coordinates on the original line. So for instance, this point has coordinates -1, 1, 2, 3, 4, 5, 6, -6. So the inverse will have coordinates of -6, -1, right? This one, which is at 0, -4, will now be at -4, 0. This one, which is at 1, -2, will now be at -2, 1. Here, where we have 2, 0, we'll now have 0, 2. Here, 3, 2 will now be 2, 3. This one, which is at 4, 4, stays exactly where it is. And this one, which is at 1, 2, 3, 4, 5, 6, will suddenly be at 6, 5. So let me graph that. Maybe do it, well, I guess we'll just do it in blue. All right, and it's going to look something like this. Extend it a little bit this direction too. All right, there's my inverse. What can be said about the graphs of y equals 2x, that's this one, y equals 2x minus 4, sorry, and its inverse, y equals x? Anything? Anything you can say about them? Well, you can say they are symmetric. That's the word. They are symmetric across y equals x. Remember, what that means is that if I literally flipped this graph over that line, if I folded this graph paper along that line, these two lines would fall on top of each other. Now letter D says, find the equation of the inverse in y equals mx plus b form. Well, we can do that pretty easily. Let's just take a look. It's got a y-intercept of 2. Right, it's right here. Its slope, well, if I go 2 to the right and 1 up, it looks like its slope, change in y divided by the change in x, will be 1 to 2. So that's going to be y equals 1/2 x plus 2. All right, that's easy enough. Now letter E is a little weird. It says, find the equation of the inverse in y equals x plus b divided by a form? Okay, well, I can actually just do that from this equation. Watch. I'm going to just call that x divided by 2 plus 4 divided by 2, right? I'm just getting a common denominator. So y will be equal to x plus 4 divided by 2. That's my inverse. Now the reason that I wanted you to do that The reason I wanted you to do that was to compare the inverse with the original function. Compare these two. In this function, we take the input, we multiply by 2, and we subtract 4. In this one, we add 4 and we divide by 2. Notice how we're doing it in the opposite order. Everything's opposite. Multiply by 2, subtract 4, add 4, divide by 2. So the inverse undoes what the original function does and in the opposite order, which is really kind of cool. All right, this is going to eventually lead us to how we find the equation of the inverse in a way that's maybe a little bit easier than what we did here. But for now, pause the video and copy down anything you need to. Okay, clearing out the text. Exercise number 2. Which of the following represents the equation of the inverse of y equals 5x minus 20? All right, so let's talk about how you find equations of inverses. This is a procedure, kind of an algorithm, but it's really cool because all you do is, it's really step by step, is you switch x and y. So that'll be x equals 5y minus 20, and then you solve for y. But be careful. All right, in fact, let's do it. Let's solve this thing for y. Well, I'm going to just rewrite it real quick. X equals 5y minus 20. To solve this for y, the first thing I'm going to do is add 20 to both sides. I think I'm going to then rewrite it like this, x plus 20. And now I'm going to take a look at all those answers. Notice how they all have kind of a 1/5 sort of in them. I'm going to put a 1/5 on both sides. Now, this is the tricky part. Did you notice how I kind of threw in those parentheses? It's very important that that 1/5 multiplies both the x and the 20, not just the x. And there's our equation. All right, so we switch x and y, and then we carefully solve for y, and that gives us the inverse. The reason that this works is for 2 reasons. The first reason being that what the inverse does is switch the roles of the input and the output. So it kind of makes sense to switch x and y. But then in the process of solving for y, you literally bring in every inverse operation that the original function, or from the original function. So in other words, the original function had us subtracting 20 and multiplying by 5. In order to solve for y, we had to add 20 and divide by 5. And therefore, we get a function that has all the inverse operations, but in the opposite order, which is what you need. All right, pause the video now and write down anything you need to. That whole issue with inverse functions, whether they're linear or not, having exactly the opposite operations or inverse operations in the opposite order makes some sense. If you think about it, it's what I call the shoes and socks idea. You know, in the morning, I pull my socks on, and then I pull my shoes on. At night, when I take them off, I take the shoes off first, and then I take the socks off, right? So I actually have to take the things off in the opposite order in which I put them on. And that makes sense. Either that or I'm going to end up with a sock pulled over a shoe, which would be a little weird. All right, let's move on to the next exercise. Exercise 3. Which of the following represents the inverse of this linear function? So we are talking about almost exactly the same problem, all right, but with the numbers changed. So why don't you go ahead and challenge this one? All right, this one's a little bit harder because the slope of 2/3 is not nearly as nice. But watch as we go through exactly the same process. We're going to say x is equal to 2/3 y plus 8. All right, so first things first, we switch x and y. Then we're going to solve for y. Now again, we have to be very careful. You know, even more careful than we were in the last problem. Get those parentheses around that. Boom, 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 boom. Distribute the 3/2. We'll have y equals 3/2 x, and then we have to multiply 3/2. I don't want to use an x there, by 8. So that'll be 12. There it is. Choice 2. All right, switch x and y. Carefully solve for y. Okay, I'm going to clear this out, so pause the video if you need to. All right, there it goes. Holy cow, we just keep getting it. Number 4, what is the y-intercept of the inverse of y equals 3/5 x minus 9? I need the y-intercept of that inverse. Oh boy. Well, lots of different ways to do this. Why don't you pause the video and think about it a little bit. Okay. Well, I suppose the most straightforward way to figure out the y-intercept of the inverse would be to come up with the equation of the inverse. In other words, if I say x is equal to 3/5 y minus 9, add 9 to both sides, multiply both sides by 5/3, and we'll get y equals 5/3 x. Now we have to think about what 5/3 times 9 is. And that's plus 15. So the y-intercept is 15. That's pretty much the most straightforward way of doing it, right? I mean, if I know how to identify the y-intercept by just looking at the equation, then obviously if I can find the equation of the inverse, the y-intercept's not that bad. Okay, I'm going to clear this out, so pause the video if you need to. Okay, here we go. Lots of multiple choice questions in this lesson, but they're good. They're good to play around with. Number 5, which of the following would be an equation for the inverse of this line? Now they gave me a line in point-slope form, and I want the inverse. Well, the procedure doesn't change. It doesn't matter whether we're dealing with a linear function in y equals mx plus b, or a linear function in the point-slope form. The plain fact is, step 1, I'm going to switch x and y. Step 2, I'm going to solve for y. Now, what's a little bit tricky here is it would be very tempting to distribute the 4 and do a bunch of other manipulation. But take a look at all of these equations. They're all in point-slope form. So instead of distributing that 4, what I'm going to do is I'm going to multiply both sides of my equation by 1/4. Those two will cancel. And believe it or not, I'm done. Right, there it is. Y minus 2 is equal to x, or is equal to 1/4 x plus 6. Oh, there it is. Right? Same procedure. We switch x and y, and we solve for y. All right, I'm going to clear this out. Or I'm going to try to clear it out. There we go. Okay, another point-slope form. Which of the following points lies on the graph of the inverse of y minus 8 equals 5 times x plus 2? Explain your choice. Well, think about this. All right, there's a lot of different ways to do it. There is one way that's a little bit, let's say, quicker than the others. But play around. All right. Well, I mean, one way of doing it, I'm not going to do it this way. I'm going to show you the quicker way. But one way of doing it is actually to come up with the equation of the inverse, plug in every one of those points, and see which one lies on it. All right, but here's what's real easy. We should be able to look at this and say, oh, I can tell that the point -2, 8 lies on that function. Think about it. Y minus y1 equals m times x minus x1. Right? So therefore, x1 is -2 and y1 is positive 8. Now, that means the inverse must have these two flip-flopped. The inverse must contain the point 8, -2. And there it is. All right, that's a little tricky because what it means is I've got to be able to look at that point slope form, read off the point, negative 2 comma 8, and then flip them to get the correct point. All right, I'm going to clear this out. Here we go. All right, let's take a look at one last one. Which of the following linear functions would not have an inverse that is also a function? Explain how you made your choice. There's a lot of good ways of thinking about this, but take a look. One of those linear functions, and they all are linear functions, would not have an inverse that's also a function. Let's go through it. Well, the correct answer is choice 3. Now, many people might choose choice 3 because they might look at it and go, well, that's the only one without an x in it, and that's not a bad way to think about it. One way to think about it is that y equals 2, beautifully drawn, is a horizontal line. Still means it's a linear function, but it's a horizontal line. Therefore, right, it fails the horizontal line test. Horizontal line test. Therefore, it doesn't have an inverse that's a function. Another way of looking at it is that if I flip-flopped, the variables, its inverse, quote unquote, would be x equals 2. Definitely not a function. This is a vertical line. Right? Vertical lines are most certainly not functions. All right, so choice 3. A little tricky, but it brings in that whole one-to-one function piece, horizontal line test, etc. All right, I'm going to clear this out and we'll finish up. So in today's lesson, what I wanted to do was review a lot of the basics about inverse functions, about how to graph them, their symmetry across the line y equals x, but also develop the way that we find the formulas for inverse functions. That's going to be very important this year. And if you take pre-calculus next year, it'll also be important there. And the method's pretty easy. Switch x and y, because that's what inverses do, and then solve for y. All right. Well, thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.